Okay, good morning everyone. So today we are going to be configuring the access and production side of the network. So we'll get the devices set up with their IPs, give them a name, get them on the network. We will set up the two access switches. So we'll be setting up the VLANs for these, the management interfaces, a bit of spanning tree, and then the port channels, so the trunk and the Etherchannel back up to the core. We'll also, if we have time, jump on the core and configure a spanning tree on there, the VLANs, the gateways for all the access and production networks that we're going to be using, and the Ether channels back down to the access switches. Okay, so let's start our devices up. So we'll start from the top and work our way down. Okay, so first thing we want to do is give it an IP, 10.11.65.11/24 mask, and the gateway is going to be 65.1. Okay, we'll also give this a name so that it actually means something to us going forward. So RDT1. Yep, there we go, and we will save the configuration on here. Great. Next up is the voice IP phone. So obviously these aren't actual phones or even virtual phones or even a virtual RDT. They're just virtual PCs that will give us a MAC address and allow us to just use it as a node on the network. 10.11.134.11 24-bit mask, 34.1 is the gateway. Right, we'll give it a name, a voice one, and we will save it. Yeah, give this a name, client 2, and we'll save that. Now client 1 is a bit different. Client 1 is an actual virtual machine. So when we come later in the lab to doing ICE and DHCP and stuff like that, we're going to use client 1 as a virtual client, so we can do a bit more with it than the virtual PCs. Okay, so 10.11.128.11.128 as its .1 as its gateway. Nope. Right. Yep, so initially we'll configure all these as static, and then when we get round to turning on the Windows 2019 server in the DC and setting that for DHCP, we'll go back and put these on DHCP. Okay, so that is the clients configured. So we'll start with switch 11 for the switch configuration. Okay, so we could do this in two ways. We could look at our initial design to get all our VLANs and our IP addressing. However, the way the network's designed is that the third octet, so here for instance 10.11.134 is VLAN 134, so it's pretty self-explanatory. Apart from the management VLAN, which is VLAN 2. Okay. So on here for switch 11 we will have VLANs 128 through 132. And this is switch 11 client. VLAN 129 is voice. VLAN 130 is switch 11 Wi-Fi guest. VLAN 131 is switch 11 Wi-Fi corp, and 132 is switch 11 print. So that's all the VLANs configured. Next up would be spanning tree for these VLANs. So if we set the mode first, the mode we're going to go for, and if we look at the different options, we're going to go for rapid per VLAN spanning tree. So spanning tree VLAN 2, 128 through 132. Yeah, we're going to set the priority 32768. That is the default priority anyway, but I like to just hard code it just to make sure. Okay, and next up we will set up the management interface. Interface VLAN 2, IP address, and it's 10.11.2 is the network, and the last octet is the number of the switch, so this one's .11. It's a /24, and we will unshut it. Next up we will configure the interfaces. So we'll start with the client facing interfaces. Interface gig 02, we will give it a name, is client 1, and this will be a access port. The access port will be in VLAN 128. We will tell it only to be an access port with the command switch port no negotiate, so this stops it negotiating to a trunk if something else is plugged into it. We will turn on spanning tree BPDU guard, and we will turn on port fast as well. Okay, next up is the interface to client 2. So we can cheat a bit here, so we'll just go up to the previously entered commands, client 2. It is an access port. This one is also in VLAN 128. We also want it not to negotiate to be a trunk. We want BPDU guard on, and we want port fast. There we go. So next up are the interfaces from the access switch facing the core. and these will be in an Etherchannel, and these will be a trunk interface. So these are going to be configured the same. So for this, we can use the interface range command and then specify both interfaces, so 0/0 and 0/1. Switch port mode trunk. Okay, so switch port trunk encapsulation .1q. Switch port mode trunk. Switch port trunk allowed VLAN. So the VLANs that are going to be on this interface are 2, 128 through 132. We will tell the native VLAN to be 666. We won't actually use the native VLAN on here. And then finally we'll set up the port channel group. And with the port channels as well, I use the number of the switch as the port channel number. The mode, and you can see the different modes here. So active and passive relate to LACP. Desirable and auto relate to PAGP, and on is just manual. For these we are going to be use LACP, so we will go with active. Okay, great. And now we need to configure the port channel interface itself. So if we cheat here and we do a show run interface gig 0/0, what we just configured. If we go into interface port channel 11, we can pinch these commands here and just paste them into there. Okay, so did we miss off? Yeah, okay, so that command here, negotiation auto, we missed off the switch port no negotiate command by the looks of it. So we'll stick it on to the port channel, which then should replicate that down to the actual ports. And we can confirm that by looking at, yeah, there we go. Yep, so that's VLANs, client-facing interfaces, spanning tree, and the uplink configured. So we'll save our config there. In fact, we will change the host name of the switch. And save our config. Great. And we'll do the same on switch 12. Okay, so VLANs up first. So VLAN 2, management VLAN up first, and that is the switch management VLAN. We have another VLAN on here, 65, which wasn't on the other switch. And this one is the Wi-Fi RDT network. And then we have the same 5 VLANs, just different numbers now. So 133, and this is switch 12 client, 134, switch 12 voice, 135, switch 12 Wi-Fi guest, 136 is Wi-Fi corp, 137 is the printer VLAN. Okay, next up is spanning tree. We'll again go for rapid per VLAN spanning tree, and we will manually set the priority of this. for 265, 133 through 137. The priority again 32768. We will set up the management interface and give the switch an IP address of 10.11.2.12, 24-bit mask with no shutter interface. And we will do the client facing ports. The first up is gig 0/2. So this is the RDT device. It'll be an access port. It'll be in VLAN 65. Don't want it to negotiate to a trunk. Turn on spanning tree BPDU guard, and we'll turn on spanning tree port fast. We'll configure interface 0/3, which is our voice. Make it into an access port. Stick it in VLAN 134. Make sure it doesn't negotiate. Turn on spanning tree BPDU guard and turn on spanning tree port fast. Okay, now time for the uplinks. Okay, again, so we can use the interface range command because the two ports will be identically configured. We know we need the switch port trunk encapsulation .1q command. Depending on the age of the switch, you don't always need this. We do the switch port trunk encapsulation ? ISL is not really used anymore, so this command's not really needed because .1q is the standard. Yeah, switch port trunk, load VLAN. We have 265, 133 through 137. Switch port no negotiate, and then we want to set the ether channel up, so channel group 12, node active. There we go. And we will do our cheat where we look at the configuration for the port we just add. Interface port channel 12, and we'll copy these commands without the channel group. We put that in before. And we will change the host name of the switch as well. Switch 12, and we will save our config. Okay, so let's configure the core switch. Okay, so we're not going to configure everything from scratch. We will just paste in a lot of the stuff that we've done already. So here I have a list of the VLANs that we just configured. There we go, done. So spanning tree mode, rapid per VLAN spanning tree. Spanning tree for VLANs 2, 65, 128 through 137, we'll use a slightly different command here. So if we go for root primary, this doesn't give it a value as such. What it does is it listens for other values that the other switches in this binary tree topology are configured with, and just make sure that the priority on the core is lower, so therefore it always remains as the root. We will configure our gateways, so interface to IP address 10.11.2.1 /24, no shut that. No, we don't have an SVI for VLAN 65. That will, because it's a production VLAN, that will pass through the core at layer 2, and the SVI for that will sit on the firewalls. Interface VLAN 128 is up next. Okay, and I have the rest of the VLANs or the SVIs scripted here, so we'll just copy them and paste them in. This is all the gateways or SVIs for the VLANs that we just configured on switches 11 and 12, minus VLAN 65, which is the production one, which will terminate on the firewall. Okay, so next up is the port channel configurations. So we can see on the core, if we do switch 11 first, we are after ports 20 and 21. And again, because they're going to be identical, we'll use the range command. With switch 11, we have VLANs 2, 128 to 132. I have a feeling that we missed that command off one of the access switches. Okay, so it's on that one. Maybe we missed it off 12. Yeah. Okay, so the good thing about port channels is you only have to configure it on the port channel itself. And there we are. Okay. Yeah, and that's exactly what we saw there. So this is telling us that the native VLAN, when we configured it on this port here, was 666 on our side, but was 1 on switch 12. And we've just configured that, so the messages have stopped. And we want to stick this into channel group 11, mode active. We'll rob these commands. Interface port channel 11 and paste them in there. We will do the same for the ports facing to switch 12, which are gig 1/2 to 3. Switchport mode trunk. Switchport trunk allowed VLAN. On here we have 265.133.137. Channel group 12, node active. Interface PO12, we'll do show on interface gig 1/2. Rob these commands, paste them in. We will change our host name. It's called access core. Really, it's an access core and a core switch. It's kind of multi-function, this switch. Okay, so let's see what we can see. So let's check our interfaces. Okay, so we have a trunk configured on 1/2 and 1/3. That's correct. 2/0, 2/1. That's correct. And we have the port channels for 11 and 12. So let's, first off, let's do a show CDP neighbors. And we can see switch 11, switch 12, so layer 2 is good. Let's have a look at our port channels. Okay, so port channel 11 is up using LAC-P on ports 20 and 21, which is correct. Port channel 12 is up using LAC-P on interfaces 1, 2 and 1/3, which is also correct. Okay, so let's do a show IP arc. Okay, so all the .1s are the interfaces that are configured directly on the switch. We are seeing our client 1 IP address. Okay, and that could be the Windows firewall stopping that. Let's see if we can see .12. Okay, so let's jump on to client 2. Yeah. Can we ping the gateway from here? Okay, interesting. So let's double check our work. So IP 10.11.128.12, that's correct, 24-bit mask. Gateway 10.11.128.1, that looks right. That connects to 0/3. Yep, and that's in VLAN 128. We have our trunk links. Could be as part of the port channel. Okay. VLAN 128 includes 0/2 and 0/3, that's right. .128 is going over the trunk, that's right. To 11, VLANs 2, 128, and 132. Interesting. Okay, so we're seeing .1 in the op table. Able to ping it. Okay, maybe that's some behavior of the virtual PC. Let's have a look on our client 1. And yep, we're seeing 128.1. And we can ping our gateway. So that must be some behavior of the virtual PC that isn't allowing us to ping the core switch, but that's fine. We can work with that as long as we know about it. So I think that's safe to say that that's that part of the network complete. Okay, so going forward, we will finish off the base configuration for the rest of the network, so the DC zone, the DMZ zone, probably the firewalls. And then we'll return to the access and production zone to set up port security in the first instance. And then we'll start to turn on DHCP once the AD's configured. And then eventually, once we've got ICE up and running, we'll then migrate this away from sort of static port configuration into dynamic port configuration, and the clients will just patch into any port and the ICE server will tell it what VLAN to be in and will authenticate it as well. Okay, hope you've enjoyed the video. If you have, please like, share, subscribe, and thank you for watching.